So the second week, or the second lesson of week 7 is talking about, we're still talking about trig functions, but we're something called inverse trig functions. And this is kind of where the magic of mathematics starts to happen for you. Let's look at this problem and start with a real life situation. So Mr. Gao needs to build a wheelchair ramp for the school's auditorium. The ramp must rise a total of 3 feet. I highlighted that because I need that information. From the ground to the entrance of the building. In order to follow the state building code, the angle cannot exceed 4.76. So let's see what that looks like. Here we have his plans. We're going to draw that it's 3 feet tall, and his plans say that the ramp is going to start 25 feet away from the building. Will the ramp meet the state building codes? So this is 25 feet. If we finish up this triangle, we basically want to know what this angle is. Will this angle be less 4.76 degrees or less? It can be less. Now this is called using inverse operations because we're undoing what we've done in the past. So before, if I looked at this, this is my hypotenuse. This is my 90-degree angle. This is my hypotenuse. If this is my angle of reference, my arms are touching the hypotenuse and the adjacent side, so it makes this one my opposite. Well, in all the problems we had on the previous page too, we knew what the angle was, but now we don't. So we're going to use the trigonometric ratio to undo it, just like I can undo addition with subtraction, or multiplication with a division, or squaring by taking a square root. Those are all called inverse operations. Thus, this is called inverse trig. And what it looks like on your calculator is inverse sine, inverse cosine, and inverse tangent. Here are the written out in words right here. And we want to, that's when you use that to find the angle. And I make a little reference that the angle is on the inside right here. So when you're looking for something on the inside, you use the inverse. And I kind of also joke that we shouldn't call it the angle, we should call it the in-goal, because it's in the in-goal, you use the inverse, it's on the inside. So first we want to learn how to use the calculator. So we're going to verify that cosine of, so here, let's just label this. This is my hypotenuse. Here's my arms. This is adjacent. So cosine, C, is 8 over 16. But if I didn't know that that was 60 degrees, if I did inverse cosine of 8 over 16, I should get 60. And here's how you do that. Let's go to the Desmos calculator. Desmos scientific calculator. And to access the Desmos scientific calculator, you have to hit this function key right here. So you see sine, cosine, and tangent are right here, but if you hit the function key, now you see inverse sine, inverse cosine, and inverse tangent. And on that problem, we wanted inverse cosine of 8 divided by 16. And when you do that, look over here, we get 60. So we know our calculator is working right. If you're using your phone, or you're using, maybe you have a calculator at your house, it might be in the wrong mode. So this is a way to check it. And you want to do inverse cosine of 1/2 is 60 degrees, or inverse cosine is 8 over 16. All right, so let's look at our next problem. Return to our diagram. Oh, we've got to go back to our paper so you can see what I'm doing. It does help to see what you're doing, right? Okay, so here we wanted to check that you can use inverse cosine on the calculator. Okay. Return to your diagram from part A. According to the plan, will the angle, okay, I'm going to redraw that little picture down here. Okay, we knew that this was 3 and this was 25, and we're looking for this angle right here. Okay, so let's label our hypotenuse. And if this is my angle of reference, this is where I'm standing. So I'm touching the hypotenuse and the adjacent side, which makes this one my opposite side. So again, I'm going to circle that I have opposite and adjacent. So we can still use SOHCAHTOA. And we have opposite and adjacent, so we're using tangent. And since we're using tangent, okay, we can set this up. Tangent of, we don't know what the measure of that degree is, right? We don't know. That's what we want to find out. But we do know it equals 3 over 25. If you don't know what the angle is, then you're going to switch it up, and it's going to be written as inverse tangent of 3 over 25 equals the unknown. This is a 25. Okay, so let's go back to our calculator, and we're going to use inverse tangent right here, and we're putting 3 over 25, and we get 6.842. So we know that the angle equals, oh, let me go back to my paper, 6.842. 6.842 degrees, right? Well, I guess it'd be 6.843 or 842. Yeah, 842. Okay. 6.842. Is this smaller than what we wanted? Let's come back here. Remember, it had to be less than 4.76, less than 4.76. So no, this is not going to work. This is not going to work. The question says, will the ramp be to code? No, the ramp will not be to code. Okay. Usually with a word problem, you have your answer in a complete sentence. So if we want it to be to code, okay, how long will the ramp have to be? So we know it's 3 feet. Now we don't know what this is, but we do know that this angle needs to be at least 4.76. Let's at least use that measurement right there. So now again, let's label everything that we know. If this is my 90 degrees, this is my hypotenuse. I'm still standing at the same thing, so this is still adjacent and this is still opposite. But now we're not looking for the angle, we're looking for a side length. So if I have adjacent and opposite, okay, that's going to be SOHCAHTOA, it's going to be tangent. So tangent of 4.76 equals 3 over x. Now we don't know how long it needs to be, so we're going to do some math here to figure that out. 3 equals x times tangent 4.76. Divide both sides by tangent 4.76. Tangent 4.76. And you're going to get x equals, let's go back over here to our calculator. And let me clear everything. And we're going to get 3 divided by, now I want regular tangent here, 4.76, and we get 36.027. So I'm going to round that to 36.03. 36.03. Go back here, 36.03. 36.03. Okay, so it's going to be quite a bit longer. Now, it can't be 25 feet. It has to be 36 feet. Okay, so we need to say that. The ramp will need to be at least 36.03 feet. All right, kind of cool when you figure that stuff out, right? Let's look at the next page. I'll do a little bit, setting it up exactly the same. We're doing more practice. Okay, so we still have our reference picture that we did on the other homework page, cosine, sine, and tangent. But now you would use the inverse if you're looking for the angle. This symbol right here is called theta. It's a Greek letter. It's often used in mathematical problems. You've already seen it. So here's our reference angle. This is my hypotenuse. I know it's my hypotenuse because it's across from the 90 degrees. Okay, so if I'm standing here, my arms are touching, always touching the adjacent side, so this becomes my opposite. I'm going to circle what I know. I have adjacent and hypotenuse. SOHCAHTOA. Adjacent and hypotenuse, so I know it's going to be cosine. So cosine of theta equals adjacent over hypotenuse. So if I don't know the angle, I'm going to just flip it around And the next step is going to be inverse of 12 over 24 equals theta. And then we're just going to go to our calculator and we're going to type inverse cosine of theta. So let's clear all. Inverse cosine of 12 divided by 24, it equals 60 degrees. That makes sense because remember the other problem was 8 over 16, the practice one. 8 over 16 reduces to 1/2. 12 over 24 reduces to 1/2. So we get that this is 60 degrees. Okay. All right, here's my hypotenuse. This one I should pay very close attention to because what did we talk about when you have legs the same size? Well, if you don't remember, let's just go ahead and set this up. Here's my reference angle, so I'm standing here, my arms are going this way, hypotenuse, adjacent, and this makes my opposite side. So we're going to go tangent theta, because that's the measure of the angle, equals 8 over 8. And so we're going to go inverse tangent of 8 over 8, or 1. I'll just go ahead and reduce that to 1, equals theta. And then type that into the calculator. And you should remember that it's 45 degrees, because whenever the two legs are equal, then the two angles are equal. And the only measure that these two angles can be when one of them is 90 and these two have to be the same are 45 and 45. 45 plus 45 is 90, plus 90 is 180. Let's look at the next problem. Here's my reference angle. This is my hypotenuse. I'm standing here, so my arms touch the hypotenuse and the adjacent side, which makes this side my opposite. I'm going to circle the pieces I have. I have opposite and hypotenuse. Opposite and hypotenuse. Opposite hypotenuse. Okay, that's the S, or sine. So sine of 57 equals opposite over hypotenuse. Now, because I have the measure of the degree here, I don't have to do inverse. I'm just going to set this up and do the proportion, stuff that we've been doing already. 7 equals x times sine of 57. Divide both sides by sine of 57. 57, and you're going to get x equals something. You're going to tell me what that equals when you do your homework, right? Your homework includes all these problems, these 1, 2, 3 problems down at the bottom, where you're going to do the inverse here. And then this one, it says, tell me 2 ways to get measure A. So you're going to choose sine. Actually, you can tell me 3 ways to get measure A. Sine of A equals what? Cosine of A equals what? And tangent of A equals what? You can figure all those out because this is your reference angle. And your arms are going to go this way. Actually, let me draw that a little better because I think I drew it worse. Okay, so label from that point, then you can tell me what each of those measures is going to be. All right, there's your homework for worksheet 4 to finish that up. Have a great day.